Hello everyone, I'm Dr. Swati Dubey and I'll be talking about glycolysis today. Glycolysis is a very important 4 by 5 star topic of biochemistry, and everyone who is going to give exams for INICET or NEET PG or next have to be doing this table very nicely. All these steps involved, number of ATPs formed, where is the site, what are the types, everything. So let's start without wasting any time. So, glycolysis. What is the other name of glycolysis? See, now you will be like, why do we need to know the name of the glycolysis? Because the thing is, glycolysis, they could just ask you how many steps are involved in glycolysis. But what they if they ask you how many steps are involved in EMP pathway? So, if you don't know about it, then you will be knowing the answer. Still, your question will be wrong. Okay, so the other name for glycolysis will be EMP pathway. You don't need to know the full name of it. Okay, EMP is the name of scientists who were behind this concept. So Ember, Matthew, and so this we can just skip the name. Okay, they'll give you only one option, EMP. Okay, the site will be cytoplasm. Where does it take place? Nucleus or cytoplasm? Cytoplasm. Cytoplasm is the site of glycolysis. What is the aim of glycolysis? Aim of glycolysis are two: oxidation of glucose to provide energy. We have glucose, okay, and we will oxidize it to provide energy. How will we form energy? In the form of ATP. Oxidation of glucose to provide energy in form of ATP. So we'll form energy which will be not as energy but the amount of ATP which is produced. ATP is like the energy of the cell, okay? And this is one of the aims. And second, it will form intermediates. Intermediates which will help in going to different cycles and different metabolic pathways, okay? And it will be useful like in the TCA cycle or the HMP shunt. Now, what are the end products of glycolysis? Before the knowing the end products of glycolysis, we'll have to know there are two types of glycolysis. Two types of glycolysis include aerobic and anaerobic. Aerobic glycolysis. Aerobic glycolysis will be your in the presence of oxygen. This is the common basic knowledge which you keep. And anaerobic will be in the absence of oxygen. Okay, now where is oxygen absent? Like RBC. RBC will be lacking mitochondria, no mitochondria, ठीक है, इसीलिए there will be no oxygen to anaerobic glycolysis, and the end product will be lactate, 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 okay? And aerobic, the end product will be pyruvate. We'll see how is pyruvate formed and how is lactate formed. What is the end product of aerobic glycolysis? Pyruvate, okay? What is the end product of anaerobic glycolysis? Lactate. Now we have to know about the steps involved in glycolysis, and the steps involved will be along with the enzymes and some of the important points which you need to know, remember, okay? So these are very important, okay? Just in a gist, if you study these things, at least you'll be able to write your MCQ portion, okay? And if you have to learn it in more detail, you can just check on the book. But even this information which I'm giving you, you can write it as a long answer because it is a 15 to 20 minutes long video about glycolysis. Okay, the first step will be glucose to glucose 6 phosphate. How is glucose to glucose 6 phosphate formed? That means to glucose we added one phosphate in the sixth position. Okay, so one phosphate was added in the sixth position. Now, where did the phosphate come from? The phosphate came from ATP. You will be like, ma'am, we were just going to use ATP for in the form of energy, but how is it being used here and not formed here? So ATP is not being formed in the first two, three steps. Okay, two steps are there in which ATP will not be formed, and there are few steps in which then ATP will be formed. Okay, so the net result will be formation of ATP. Okay, but there are two steps where ATP is used and you need to remember it for the exam. So ATP will form ADP, and then one phosphate will go to glucose and form glucose 6 phosphate. Okay, the enzyme which it uses is hexokinase or glucokinase. Okay, and the cofactor will be magnesium, okay, or manganese. Okay, what are the important remarks on this step. See, this is a irreversible step. Now from glucose 6 phosphate you can't form glucose, okay? So it is a first irreversible step of glycolysis. There are three irreversible steps and all other are reversible. This is the first of them, first of the lot, which is the irreversible step of glycolysis. Now the next part is glucose 6 phosphate forms fructose 6 phosphate. How does glucose 6 phosphate form fructose 6 phosphate? It will just change the isomerization. Okay, you have studied glucose is an aldose, fructose is an ketose. Okay, so an aldose will turn into ketose. So it is just the isomerization. Okay, so isomerization, how is this isomerization happening? What is the enzyme which is being used? It is phosphohexose. Okay, there is phosphate group which is being changed. Okay, hexose because it is a 6 carbon compound, phosphohexose isomerase. Okay, and this is a reversible step. This is a reversible step. Okay, this is a reversible step. This is the point which you have to remember. Okay, just this much. Now fructose 6 phosphate is converted into fructose 1,6 bisphosphate. That means one more ATP is coming here. I told you there are two steps where ATP is being used, okay, to form ADP and give one phosphate each. Okay, so first phosphate was given to glucose, second phosphate is being given to fructose 6 phosphate to form fructose 1,6 bisphosphate. And the enzyme which is used here is phosphofructokinase. Okay, PFK, phosphofructokinase, PFK1. And this is very important because this is the rate limiting enzyme or the rate limiting step. Okay, step rate limiting step or enzyme is the rate limiting enzyme. This is the committed step. Okay, the bottleneck this one is committed step. And this is the second irreversible step, second irreversible step of glycolysis. These are very important. Okay, this is the second irreversible step of glycolysis. Now the third part we come to, the next part we come to is fructose 6 phosphate. It is a 6 carbon compound, right? But this 6 carbon compound we will break it into 3 carbon and 3 carbon compound. Okay, those 3 carbon and 3 carbon compounds which are formed from fructose 6 phosphate will be dihydroxyacetone phosphate and glyceraldehyde 3 phosphate. Even this is a reversible reaction. Okay, and this is changing and the enzyme is aldolase. Okay, but dihydroxyacetone phosphate is not used in glycolysis, so it will also be converted into glyceraldehyde 3 phosphate. Now both are 3 carbon compounds, so there will be isomerization, and this is phosphotriose, 3 carbon sugar, right? Phosphotriose isomerase. Okay, so glyceraldehyde 3 phosphate is my main compound which I am getting. Now from here I will continue this. I have now 2 into 2 into 2 into 2. Whatever I get will be 2 compounds from here because all are 3 carbon from here. 3 carbon. No, but we had 6 carbon, so we had divided into 2, the 3 carbon. Okay, glyceraldehyde 3 phosphate will now be converted into 1,3 bisphosphoglycerate. Okay, this is a very important step. Okay, here one NAD is being converted to NADH. Okay, remark here is one NADH has how many ATPs we consider? 2.5 ATP. So now here we have ATP formation. Okay, and here we have ATP formation and twice NADH will be formed because I have two molecules of glyceraldehyde 3 phosphate. This is also reversible reaction. Okay, this is also reversible reaction. So just a review of what we were studying. Okay, we'll just revise once what we were studying. Glycolysis, what is the other name of glycolysis? EMP pathway. And where is the site? Cytoplasm. What is the aim? Oxidation of glucose to provide energy. What form will energy be in? ATP. What is the other aim? It will form intermediates or metabolites, okay, for the metabolic pathways. What are the end product? There are two types, aerobic non and anaerobic. Okay, aerobic will form pyruvate and anaerobic will form lactate. What are the steps involved? Steps will be glucose is converted to glucose 6 phosphate and the enzyme is hexokinase glucokinase. Okay, and this is the first irreversible step of glycolysis. Then glucose 6 phosphate is converted into fructose 6 phosphate. Okay, this is phosphohexose isomerase. This is a reversible reaction. Now fructose 6 phosphate is converted into fructose 1,6 bisphosphate and then again ATP is being used. Okay, and the enzyme is phosphofructokinase. Okay, this is PFK1. This is very important. Okay, it is the rate limiting enzyme. This is the committed step and this is second irreversible state. Then fructose 1,6 bisphosphate from dihydroxyacetone phosphate and glyceraldehyde 3 phosphate by the enzyme aldolase, and dihydroxyacetone phosphate will be converted into glyceraldehyde phosphate 3 phosphate because dihydroxyacetone phosphate is not in our use for glycolysis. So glyceraldehyde 3 phosphate will be now from here used at two different compounds. Okay, and then whatever we get from here will be multiplied by 2. Now, glyceraldehyde 3 phosphate will be converted into 1,3 bisphosphoglycerate, and what we use is glyceraldehyde 3 phosphate dehydrogenase. Okay, what is the enzyme? I didn't tell you. Glyceraldehyde 3 phosphate dehydrogenase. Okay, glyceraldehyde 3 phosphate dehydrogenase. Now, 1,3 bisphosphoglycerate will be converted into 3 phosphoglycerate. That means I am removing one phosphate. Okay, I am removing one phosphate. So, my ADP is converted into ATP here. My ADP is being converted into ATP. Okay, what is the enzyme which I am using? It is 1,3-bisphosphoglycerate kinase. 1,3-bisphosphoglycerate kinase. And this is also reversible. Okay, till now we have done two irreversible, glucose to glucose 6 phosphate and fructose 6 phosphate to fructose 1,6 bisphosphate. Now I have two molecules of 3 phosphoglycerate and it will convert by okay, by throwing the carbon throwing the phosphate from the third carbon to the second carbon. Okay, so this is just a mutation which is taking place. So mutase. Okay, 3 phosphoglycerate. What are we doing? It mutating. So 3 phosphoglycerate mutase. Okay, so it will form 2 phosphoglycerate mutase. Okay, then phosphoglycerate mutase. Okay, it will use enolase and convert into phosphoenol pyruvate. Okay, phosphoenol pyruvate. Okay, and it will give away one molecule of water. It will give away one molecule of water and the cofactors will be magnesium and manganese. Okay, for enolase. Now the phosphoenol pyruvate, even this is reversible. Every other reactions which we have studied is reversible. Okay, except three. First is glucose to glucose 6 phosphate. Second is fructose 1 phosphate to fructose 1,6 bisphosphate. Now the last one which we are going to do is phosphoenol pyruvate to pyruvate. This is the third irreversible step of glycolysis, and here we will use pyruvate kinase and 1 ADP will again form 1 ATP. Okay, so I am done with all these steps of glycolysis. Okay, if you have anything to copy down, you can just pause your videos and copy down. Okay, the whole one long question for glycolysis is covered here. If you write this much, you are going to score almost all the marks. Now, total number of pyruvate molecules formed. How many pyruvate is formed? I said I have 3 carbon pyruvate compound, but I had used 6 carbon, but it was getting divided into 3 carbon each. So how many? I have molecules of pyruvate. 2 molecules of pyruvate. Total ATP which is being formed. Okay. So now you can just see I have used one NADH. Okay, and it formed me 2.5 ATP. But how many NADH was being formed? 2. So 2 into 2.5 is 5 ATP is being formed in this step. Okay, why 2? Why did we multiply 2? Because we have two molecules of glyceraldehyde 3 phosphate. So twice, both the times in two different reactions, okay, it is using NAD to convert into NADH. So I have two molecules of NADH. So one molecule is giving me 2.5, then two molecules will give me 2 into 2.5, 5. Okay, and then how many ATP are being formed? Again, I have two molecules of 1,3-bis phosphoglycerate which is being converted into 3-phosphoglycerate. So I will again have 2 ATP here. Okay, so 5, 2 ATP again. Okay, 5 plus 2, 7. And again I have one more 2 ATP. Okay, again I have two compounds of phosphoenol pyruvate. So again 2. So 5 plus 2 plus 2 equal to 9 ATP which is being formed. Okay. Now total number of ATP which is being used will be, okay, I have 1 ATP which is being used here. Why not into 2? Because this whole process here is only once. Okay, once. So how many ATP is being used here? 1 and 1, 2. So how many total ATP is being used? This is 2 ATP. So net ATP will be 9 minus 2 equal to 7 ATP. My net ATP which is formed is 9 minus 2, 7 ATP. This is very important for me to remember. Okay, very important for me to remember. Now I will talk about anaerobic glycolysis. Anaerobic, I just told you, it is in the absence of oxygen because there is no mitochondria in the RBC, so there will be no oxygen, so there will be anaerobic glycolysis. And what is the end product which is formed in anaerobic glycolysis? It is lactate. Okay, first we will get from glucose, we will get glyceraldehyde. From glucose we will get glyceraldehyde 3 phosphate like we got then. Okay, and then we will get 1,3-bis bisphosphoglycerate like the whole old step. Okay, you can just review it. And then pyruvate. Okay, then pyruvate. Now this pyruvate is being converted into lactate. Okay, how does it get converted into lactate? The enzyme uses pyruvate dehydrogenase. Okay, and the enzyme used is pyruvate dehydrogenase, and NAD is being converted here. NAD is converted into NADH like we had studied. Okay, now NADH will be converted into NAD here. So how much NADH is formed? Whatever was formed, it is utilized. So no NADH. So no 5 ATP which was being formed in the aerobic glycolysis. Okay, so there will be total of only 4 ATP which was being formed here. Okay, in the aerobic glycolysis, and then 2 got used. Okay, 2 ATP was used in the beginning. Okay, so their net utilization will be, net will be only 2 ATP. Only 2 ATP will be the net ATP which is being formed. Okay, how many ATP is being formed net? 2 ATP. Okay, so my next, what is my next thing is, I will learn about some inhibitors. Okay, inhibitors are very important. We will have to remember these inhibitors. Okay, there are two inhibitors for glyceraldehyde 3 phosphate. Okay, the two inhibitors include iodoacetate, and arsenate. Iodoacetate and arsenate. Iodoacetate also inhibits glyceraldehyde, and arsenate also inhibits glyceraldehyde 3 phosphate. Okay, now enolase. Enolase, where was it used? It was used to convert your 2 phosphoglycerate into phosphoenol pyruvate. Okay, and this will be inhibited by fluoride. You have studied about sodium fluoride, NaF, which is being used in mixtures in blood glucose estimation, right? Because it will inhibit this step, so the glycolysis will not take place and we'll have the mixture, blood mixture, which will be stable with us. Okay, so this is very important, and thus we will just end our glycolysis. Okay, if you have any problem, okay, please, you can go to my Instagram page and message me, okay. I'll just put down my link, or you can just comment, okay. Please like, subscribe, okay, and press the bell icon to for more videos. And if there is any topic you want me to do in a haste, or as early as possible for your priority, you can just write down in the comment section and I'll be doing that. Thank you so much.